Exercise 12, quite a difficult exercise. This is actually RN, or exam question in RN. But it's a nice exercise. It's actually an optimization exercise this. And we have this function here, which is this graph, this blue graph here, like this. And under this graph, we're going to put a rectangle, a right angle rectangle like this. And the question is, how do we do this to maximize the area? That is exercise B, by the way, here. So the thing is, we have a function here like this, right? Something like this. And under here, we're going to put a rectangle. So we can, for example, the 0 point here is 3, by the way. We can choose x equals to 1. Then we get this triangle, which is pretty nice. Or we can choose x equals to 2. Then we get this triangle. And or we could pick x equals to 2.5. Then we get this triangle and so on. And the question is, how far do we need to go on the x-axis if we want to maximize the area of this triangle? And the first thing we'll do is find an area function like this. This is a typical optimization exercise. And then we just start with the formula for the area what you want to find, which is a triangle, which is half times base times height. And the base here is x. X is the x coordinate of b, right? So if b is over here on 2, then the base is 2. If the x coordinate of b is 1, then the base is 1. So the base is the x coordinate of b. And the height is the y coordinate of this point C. And how do we find the y coordinate of a point? If x was 2, we want to find the y coordinate here, we would calculate f of 2. If x is 1, then we would calculate f of 1 to get the y coordinate. Now the x coordinate is x, so to calculate the y value, we have to put x into the function. So this is just the function f of x. The height is restricted by its function here, by the function, which is 2x minus 3 square. So this means that the area of the triangle is 1/2 times the base, which is x, times the height, which is 2 times x minus 3 square. And then, of course, I can do like this, take away the number 2 here, so I get x times x minus 3 square. And then we just use the second binomial formula here, like this, and then multiply with x. And then we have the area as a function of f, which we call big F here. Function of x, sorry. So that's exercise A. The area function. And as I said many times before, in these optimization exercises, A is often the most difficult task to find this area function. But then you should be able to do exercise B, even if this is part 1. It's easier on part 2, of course. But in B here, we want to maximize this area, so we need to find the maximum point of this function. And to find the maximum point, of course, we find the derivative. And if we find the derivative of this function, we move down 3, so it's 3x squared. Keep the constant 6, move down 2, so we get 12x. And then the derivative 9x is 9. And then we put the derivative equals to 0. And we can use the ABC formula, and we get x is equals to something. Let's see here. If you use the ABC formula, we get 12 plus minus square root of 12 square. You have a calculator even on part 1 here. 4 times 3 times 9. That is 108, I think. So it's 36 under the square root sign. So this will be x equals to 1. And x equals to 3. But yeah, 3 is not the answer, because if x is equals to 3, this is this point here. But yeah, let's confirm that this is the maximum point. And so we have 2 stationary points now, right? 2 maximum, minimum, or terrassepunkt. And we want to find out which is which here. So we need to draw the sign line of the derivative. Then we first have to factorize it. And to factorize this, we use the factorization formula a, which is 3, times x minus the one solution times x minus the other solution. Then it's factorized, and we can draw sine lines. Sorry, like this. Kind of boring, but so then we know the sign of the product, which is the derivative here. So it's plus 0 minus 0 plus, which means that the function is increasing, decreasing, and increasing. So this is the maximum point. And what was the question? Decide x such that the area is maximized. So the answer is x. This was the maximum point here, x equals to 1. And I think I will make a new video for exercise